Periodic table and chemical bond. By MG Chem and MG School Education. Visit www.mygchem.blogspot.com. Follow MG Chem page in Facebook and subscribe MG Chem YouTube channel.
Atom. What is an atom? Atom is a basic unit of matter that consists of a dense central nucleus surrounded by a cloud of negatively charged electrons. Nucleus consists of positive charged protons and neutrons have no charge. This is nucleus, and surrounded by negatively charged electrons. Element. What is an element? Element is a substance in which all the atoms have same mass and properties. For example, hydrogen is an element. In hydrogen element, all atoms have same physical and chemical properties such as atomic number, atomic mass, electronic configuration. Atomic mass. What is atomic mass? Atomic mass is the sum of proton and neutron number in the nucleus of an atom. For example, in carbon atom, there is 6 protons and 6 neutrons. Sum of these we get atomic mass 12. Atomic mass of carbon atom is 12. Atomic number. What is atomic number? Atomic number is the total number of protons in the nucleus of an atom. For example, atomic number of oxygen atom is 8, because it contained 8 protons in nucleus. Periodic table. Periodic table is a tabular display of chemical elements, organized on the basis of their atomic numbers, electronic configuration and properties. Period means elements repeat their chemical and physical properties after a periodic intervals. Table means arrange in tabular form. Earlier attempts to classify elements. In 1789 Antoine Lavoisier published a list of 33 elements, grouped them into gases, metal and non-metals. Dobrinner's trades. In 1829 Dobrinner classified elements into groups of 3 elements with similar properties on the basis of atomic weight. Atomic weight of middle element is roughly average of first and third elements, is known as law of trades. For example, lithium, sodium and potassium. Average atomic mass of lithium and potassium is equal to atomic mass of middle element sodium is 23. Limitation. He could not arrange all the elements, only such 3 trades that have been mentioned. Newland's octaves. In the year 1866, an English scientist, John Newlands, arranged the elements in the order of increasing atomic masses. He noticed that every 8th element exhibits similar properties as compared to the first element, as like a musical note. He called this law as the law of octaves, better known as Newland's law of octaves. He arranged the elements like this: here 8th element, fluorine, exhibits similar properties as compared to the first element, hydrogen, and 8th element, chlorine, exhibits similar properties as compared to the first element, fluorine. Chlorine, fluorine and hydrogen have similar properties. Similarly, potassium, sodium and lithium have similar properties, but problem in placing transition elements. Limitations of Newland's octaves. This classification was successful up to the element calcium. Mendeleeff's periodic table. Mendeleeff's periodic table, based on Mendeleeff's periodic law, which state that the physical and chemical properties of the elements are a periodic function of their atomic masses. At the time of Mendeleeff, only 63 elements were known. He classified the elements into 7 horizontal rows called periods, and 18 vertical columns called groups. This is Mendeleeff's periodic table. He considered atomic mass for arrangement of elements. Limitations of Mendeleeff's periodic table. Position of hydrogen atom. Hydrogen atom has been placed in group 1 alkali metal, but it resembles to halogens of group 18. Thus its position in the Mendeleeff's periodic table is controversial. Position of isotopes, as Mendeleeff's classification based on atomic weight. Isotopes placed in different position due to their different atomic weight. For example, There is 3 isotopes hydrogen which occupy the different position. Anomalous position of some elements. For example, when we consider atomic weight, cobalt, atomic weight 58.9, is placed after nickel, atomic weight 58.7. In modern periodic table, arrangement of elements on the basis of atomic number, here, cobalt, atomic number 27, placed before nickel, atomic number 28. But, when we consider atomic weight, for classification of elements, cobalt, atomic weight 58.9, is placed after nickel, atomic weight 58.7. This is the demerits of Mendeleeff's periodic table. Modern periodic table. In 1913 Moseley modified Mendeleeff's periodic law. He stated that, physical and chemical properties are the periodic function of their atomic number. That is, when arrange the elements in increasing order of atomic numbers, the properties of elements repeated after certain regular intervals, 2, 8, 8, 18, 18, 32. These number called magic numbers, and cause periodicity and properties due to repetition of similar electronic configuration. Periodicity means the repetition of similar properties after intervals is called periodicity. Causes of periodicity. Causes of periodicity and properties due to repetition similar electronic configuration. The periodic table divided into 4 main blocks S, P, D, and F. Modern periodic table consists of 4 blocks, S, P, D and F. Group 1 and 2 are S block elements. From group 13 to 18 are P block elements. From group 3 to 12 are D block elements. From atomic number 58 to 103 are F block elements.